Good afternoon, ladies and gentlemen. Welcome back from your lunch. Hopefully you are still here. And also, I think I'm the only guy between you and the next tea break. So let's get started. Again, I'm Dikai. I'm from NVIDIA AI Technology Center, Singapore. I'm a solution architecture focusing on robotics and edge computing solutions. And also nowadays, you cannot go to an event talking about AI without, NVIDIA, right? So let's get started. Today, we are going to talk quite a lot of things because in these robotics domains, NVIDIA do have quite a lot of solutions and things to offer. But first of all, we all know that nowadays, robotics are going into a whole new domains. Right? So especially we are now more talking about so-called Gen AI and embodied intelligence nowadays, because it makes your robot more intelligent and can do far more things than a single task. So what is a Gen AI? So talking about Gen AI is, it's coming from the language processing things, NLPs, and you will see how ChatGPT has been growing and exploding, and it's gaining like 100 millions of users within just, I think, 2-3 months. So we all see that. And after that, all these Gen AI things have been coming from NLP to like domains in computer visions, in image generations, and nowadays it also becomes a quite important part in robotics. One key thing inside of Gen AI is, its architecture. For example, in the visions part, the key things will be our vision encoder, transformer encoder, so using these self-attention things. So comparing to what we are more familiar with, like the CNN-based solutions, where you stack multiple convolution layers, basically learnable filters to help you to find key elements, to key structures, key things to look at, and then stack them to gather these informations. In these transformer-based things, we see them as tokens. So basically, see them as a long sentence. And this sentence is generated from this image, and then we just trying to find the relations of each patch of each things for each others, and then again generate patterns, things we are interested in. So it can give you these informations. So this is a power of what powers the Gen AI and all these things. But it is powerful and has advantage of quite a lot of things over our traditional CNN-based solutions. For examples, for CNN-based methods, it's generally having a quite difficulty to handle unexpected situations. For example, you may have a well-tuned classifier, but under a lot of lighting situations, it may not still know if you have a cat or dog in your house. And also, it's very hard to generalize. Once you train for one task, it's almost fixed. You cannot to generalize or add new tasks into it easily. And it is often more for just a single thing. So if it trained for image understanding, just image understanding. However, it stops playing. I make it play again. Okay. Forgot to loop this GIF, but anyway. But with these transformer-based things, we can have a much easy way to give it to have a zero shoot or few shoot transfer to new scenario or new task. And it has much higher accuracies in most cases, and it can give you ability to do contextual understanding and to add different things into it. So it can be more than just image. It can be human input. It can be text input. Everything can be combined together into one framework. And with the very beginning of the transformer is the paper attention is all you need. We all know that it's a very famous paper coming at around 2018. And after that, we are just seeing a lot of the papers about this topic and based on transformers. We have like GPTs, also we have a bunch of like ChatGPT, these products, and also a lot of open source solutions like llamas. And it also becomes like transfers from pure text-based to multimodal and multimodality things. So we add the visions into it, becomes a VIT vision transformers. And then we even add like for robotics, we can even add actions into it. So it becomes a VLA models, vision language actions. So it can not only get information from text, from images, but it can also direct output actions for your robot. So it just opens a whole era of how AIs can help your robotics to get much smarter. And with that, these Gen AI-based things can be applied in a lot of domains. Of course, our every robot's like image computer vision stuff, like detecting defections and doing some SLAM navigations, all these good old stuff can still apply. But we can also add more things like human-robot interactions, because again we can direct talk to it, we can text to it, and we can have to describe your surroundings and help you to program the robot itself. And with this, we believe, I would say at least in this room, we believe AI unlocks a new level of autonomous, because everything it moves will one day be autonomous, right? We don't want a pilot sitting behind a screen to control it. If it can run by itself, why not let it go? So with this AI, of course, you can have a more advanced SLAM navigation functions, but it also opens opportunities for graspings, because for graspings, the first step is to detect where your object is and what it is. So it can know where your end effect goes and in what positions, and if it's a delicate object, if it to use a less force in case you crash it. And in combine, we can even use like new learning things like reinforcement learnings to train your new controllers, so it will not rely on your prior knowledge, but it can learn to run by itself in a virtual environment. And this just opens a very large market, right? So robotics are being used in a lot of domains and industries, from logistics, from manufacturing, construction, in the agriculture, retail, healthcare. I believe in this room, many of you guys coming from one of these industries, and during lunch, we also talked to someone working in constructions, working in manufacturing. So these are all the places where robots are being used or being tested, and AI will just make it much better in the future. However, of course, everything seems very bright, but as someone working with robotics will know, developing an AI is one thing, but deploying is just another challenge. So because for a lot of things I have talked about, like computer visions, like reinforcement learning agent, a lot of them are actually nowadays trained in simulations, a virtual environment, because we can be gathering more information in a much faster way and much cheaper also. And all this simulated environment and all this kind of virtual data is not exactly the same as what we see in the reality, right? Yes, we have those advanced simulation agents, physical agents, rendering agents, but it's just not the same. And in the reality, it's just, anything can happen. though we can try to simulate them using a lot of techniques, but we cannot foresee everything happens in realities. Some lighting changes, can just blind your cameras, maybe, and something may just fall down, and some human operators may just suddenly walk in front of your robot. Everything, this kind of accidents can happen, and it is very challenging for us to deploy these AI-based robots in a real world. And also, one thing is about computations. So especially for robotics, most mobile robots, we don't want a cable tangling around. We want it to work off the grid. Of course, we have batteries, we have some onboard computers on it, but with this scaling of the larger models and the things it are designed to do, can we still confidently say, yes, this model will run on this robot in real time and without any issues and not drain our batteries? These are all challenges. Of course, to solve them, there are many things we can think about. For example, the computations. There are more advanced edge AI things, from hardware power to software accelerators to libraries and even your whole architectures. And you can train a more specific robot that are designed for this more resource-constrained environment. And during learnings, you can all consider all these things about how to make this sim to real transfer more smoothly and easy to do. And of course, during the real world deployment, you can always test it beforehand in a simulations, so that you can be more confident to say, okay, it should more or less, work well in the realities. And of course, I will talk about some of our, more specific solutions targeting to these domains. So in these areas of AI coming to a physical world with embodied AIs, or more simply robotics, we have a lot of things can help to accelerate. For example, we have the AI platform, what you may know NVIDIA for. So to help you to train your models to specific for these robotic tasks and platforms. And we have digital twins platform. So previously we all heard from previous speakers about designing a digital twins and how it can help to cut costs and accelerate your deployment. So we have Olympus to do that. And we have a whole robotics things like ISAC and ISAC ROS to help you integrate your AIs, your solutions into your existing framework. So in the core of it is NVIDIA ISAC. So it is a platform to develop AI robots. So again, it has the ISAC, it has the simulations, it has the hardware platform to deployment, and all added up, we have some reference flows, like perceptors for UGV navigations. We have manipulators for manipulations, and we have project root, which is specially designed for humanoid robots. So for ISAC Sim, this is our simulation platform. So you can use it to design your robotics digital twins, which and it can be incorporated with our other solutions, so you can gather information out of it. So you can pass it to your training program to train your AIs, and it can connect to ROS and ROS-2. So and also direct Python, so you can direct program with it to test your algorithm to see how it works with your existing systems. And one key thing of it is synthetic data generations. So again, to training these AI models, normally you will need a large set of data, right? So with digital twin, you can easily generate all these things from simply RGB to ground truth like the bounding box, like a thematic instance, and then you can add something into it, like domain realizations, like what the color of this object will be, what is the rotation, what is the scale, what's the lighting kitting on it. So you can generate a diverse data set to help you to train your, for this case, of course, computer vision based solutions. Then what about controls, right? We have the visions, but we still need some controls if you want to make it end-to-end solutions. For that, we have what we call RIC Lab. So this is developing your control algorithms based on reinforcement learning or imitation learnings. So learning from generating its own experience or just learning from your demonstrations. So it is building on top of RIC. So all the physical and rendering things of goodness still happens. And then we can make it to work on multi-GPUs or even multi-node, because nowadays with the growing of embodied AIs and foundation models, these models are super large. And you can scale it up and render different perspective of the cameras are. You may fix it to your base. You may have a fixed camera in some position pointing to your object, so it can learn from the visions. And of course, nowadays to do that, it's working with large models. It's more than just a single workstations or a single unit of your servers. Nowadays, you may even consider of using a whole rack or even a whole data center to do your trainings, because your model is simply too large. We are talking about 70B, 370B large models, right? It's not the things you can train on your everyday stations. So we have what we call Osmos. So it is a framework to help you to do your task organization, to do your task scheduling, so the right server can do the right things. Some server will do the rendering, some server will do the training, and the data can be synchronized. And based on RIC Lab and Osmos, in this year's, early this year's GTC, we announced Project Root. So what we are doing is we are trying to build a generalized agent, a foundation model-based agent for human race. So one day it may help you to make you lemonade, probably. And today is ROS. So let's talk a little bit about how you can integrate with ROS. So ROS, first, so we have announced RIC ROS, and now it's already version 3.0. So what RIC ROS is, it is a framework, it is a set of packages, what we call gems, with hardware accelerations that deeply integrated with the ROS2 ecosystems. So you can directly pull down from GitHub, put in your ROS2 workspace and make it to compile and to work with your existing computer visions frameworks. So it also provides some AI-based computer solutions like visual autometries, like motions for path plannings, and like image segmentations, all these tools and existing like pre-trained AI models, so you can start testing. But of course, most time you may want to fine-tune it to suit your use cases, your data set better. And nowadays, RIC ROS has already been used with a lot of like companies in the field, like Direct Drive Tech, like FarmX. So they all use these things in one way or another to develop their own like solutions. So some of them are based on the reference framework I just mentioned, like a Perceptor, which is a reference framework for vision, for like tracking navigations. And we have manipulators. Again, the name itself says, a set of these tools like 60 pose tracking, motion plannings to operate your robot arm. So all these things are reference workflow, so you can adopt to it and you can modify it based on your needs. And some hardware, some you may know, some you may not. So our flagship is AGX O-Ring. It can run as low as 15 watt and as high as 16 watts, and depending on your configurations and on your need on what AI need to be run on it. For most cases, I would say like Orin NX or even Orin Nano should be sufficient for most use cases. But if you really go to the sky with foundation models, of course, we do have a new product coming soon. But currently, the HX Orin is our flagship product. And underneath it is our software based on CUDA. So everything is based on CUDA, so it can be transferred to from your data center to edge computing easily. And the Jetpack gives you a lot of things like platform services, basically containers for you to deploy your things. And it also has so-called solutions for different models. For examples, with Jetson AI Lab, we have these pre-optimized foundation model-based things like vision transformers, schematic anything, and track anything. So these foundation model large LM-based solutions are already pre-optimized for you, so you can test it. And all these are just directly runnable on adjacent Orin devices. And with our observation, you can see if you are just running some vision, computer vision task, it's really fast. You can, with efficient VIT, which is on the smaller smaller CV models, it can run at like around even achieving like 300 FPS. It's more than like real time. But if you are going to a more complete solution like VLM, we currently still have some difficulty to make it run, I would say fast as we like, but still something. And again, with the new hardware coming up, it will be much better. And one thing is like VLA. So again, like I mentioned, combining visions, actions, and visions, instructions, and actions into these single models. So this single model can look at the surroundings, understanding what you ask it to do, and do it. With Jetson AI Lab, this model can be directly run on a Jetson Orin, Jetson Orin AGX, running on maybe in 4 quantizations. So this is also a simple, simulation mimic gen. So you can see the task will be, cube stacking. So if you pick the cube and stack on top of it, everything just runs on the Jetson itself. So no cloud service is needed. And again, there are a lot of enterprise has been using our solutions, and also like Amazon Robotics has been using our solutions. So I would say some like AWS, just now the presentation, some videos actually captured from Isaac Sim. I recognize them. And there are also Delta, Foxconn, for Harvard, who have been building things based on the whole solutions. So that will be end of my sharings. Not sure if I have time for this video. Okay, then I will just go for it.
It's not enough for humans to imagine. We have to invent and explore and push beyond what's been done. We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. We broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason so it can share our world with us. This is where inspiration leads us. The next frontier. This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
So just a quick video to sum up everything I have just shared. So of course there are many, a lot of things I just mentioned are actually open source and free to try. And you can go to some like Isaac ROS and Isaac Lab. You can just go to GitHub and pull the repository to test it out. So that will be all for my sharings. Thank you. If you have.
So thank you, Dr. Liu. So now we will open the floor for questions. If you have a question, please raise your hand and our team will pass you the mic. But before you ask a question, please introduce yourself and also the company that you represent.
Thank you, Dr. Liu. I'm Fang Yuan. Actually, I'm from SimTech, SUL team. Yeah, urban supply chain or urban logistics, right? So actually, I just now see your framework. You're using the synthetic data to train for a model. My question is actually synthetic data is very different from the real world data. Like there's a reflection, there's the light is not very very well distributed among different areas in the room. So in that case, how the NVIDIA are going to handle this?
Yeah. So this is in general speaking, this is a limitation of synthetic data. One way, the most direct way, of course, is building a more advanced simulation platform, right? So getting more beautiful rendering. So this is what Isaac Sim is designed for. Of course, adding all the renderization into it, so make it more diverse. So this is a very direct way, and I would say it's used in every synthetic data pipeline nowadays. In advance of it, of course, synthetic data currently, even with these techniques, is still not perfect. Like you said, in the real world, is unpredictable. So in NVIDIA, I think this year or last year, we do have a research kind of paper out. So it's like you can mix your real world data and synthetic data. I would say you just mix a small ratio of real world data into synthetic data, and it will make the model more robust in generals. And one way is like in the era nowadays with foundation models, you can leverage on this, the prior knowledge of foundation models, because foundation models are mostly trained on, a large set of environment knowledge and information derived from internet, right? So there are text information, there are vision informations, and leverage on these prior informations and kind of fine tune with your synthetic data. And again, like mix a little bit on your real world, in your environment, real world data. So it will make it more robust overall. But of course, this is still an ongoing domain. So I would say there will be more kind of better solutions, techniques coming out in the future.
Yeah, I agree. Thank you for your answer. I actually know there's some cycle gain. There is some you can use the GTA data, right? Because there's some 3D gaming simulation that you can get all these big data set. Can then based on that you can build a big model for training that can produce 95% above the segmentation accuracy. What I know is based on the last year paper. But what I know is. Yeah, but 95 is still not enough for the deployment, what I mean here. So how do you handle, do you have any other plan like to integrate real data on certain area, for example, I take video of the real library environment, then or this real warehouse environment, then send you off for training?
Yes, there are several ways. One way is, actually there are real-world data sets like OpenX embodiment, right? So there are these kind of real-world data sets mostly for manipulation, I would say, but also for other robots. One thing you mentioned about is there are ways like you take a video of your surroundings, and it can actually, from that video, generate a simulated environment and augment it. So this is also one way. So again, this is still a very active domain. So all the techniques I just mentioned are fairly new. Like the taken video thing, I think it's just 2 months ago. Professor Li Feifei announced digital cousin, I believe, because nowadays we call it digital twin because they are identical. But with digital cousin, she says we can take a video and it will generate different versions of it. So, this is a very active thing, and this is a very large. This thing is a very large part of what we call sim-to-real gap, and unfortunately, it's not fully solved yet. So we can hopefully develop more solid solutions.
Thank you for your answer.
Thank you. Are there any more questions from anyone?
Hello, I'm Ricardo Tellez from The Construct, and I would like to know if you can answer the question about which type of license is required in order to use ISAC SIM, for example, for companies. It's very important.
Yeah, we do have a dedicated enterprise licensing, but if you are interested, I can direct you to a more suitable person to give you maybe pricing, things like that, right?
Okay, so there is a pricing license for companies,
yes.
But for researchers?
For researchers, we have, and also one thing is, earlier this month, we announced so-called Omniverse Enterprise. We do accept kind of application from research institute for free kind of entry. So if you are working with, you are any of an audience here today are working inside of a research institute, universities, you can apply for it. But for profit-focused companies, it has a paid license.
Okay, thank you.
Thank you everyone for participating in the Q&A. Thank you, Dr. Liu.